Welcome back, everyone. John Furrier, host of theCUBE. We are here in theCUBE's NYSE studio. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street. This is our AI Factory series. We talk to the leaders who are making it happen and building out the next generation AI infrastructure that's creating a ton of value, creating a ton of tokens, and all the new AI native applications will sit on it from core to edge and everything in between. We've got two great guests here with some funding news. Faris Sbahi, he's the CEO and co-founder, and Craig Churchill, Chief Business Officer of Normal Computing. Gentlemen, thank you for coming on the program.
Thanks for having us.
AI Factory is our hottest series because there's more money being spent on AI infrastructure. Some say a lot. Caruso's SVP of engineering told me last week, they need more funding. So a lot more action is coming into the AI infrastructure because the demand is off the charts.
Yes.
For tokens. Tokens are the new intelligence vehicle.
Yeah, I think Jensen had a great equation that he shared last week, which is that revenue equals tokens per watt times available gigawatts, right? And we're seeing the demand for tokens go up tremendously as we move to agentic AI and this sort of new paradigm of always on AI, decentralized AI. And so we're seeing that increasingly the constraint is essentially power. Yep. Which is a big part of what we're focused on at Normal and part of the needs.
He's got his favorite slide too that I call the Maslow's hierarchy of needs of AI and AI stack. Energy is at the bottom. That's like food and shelter.
Yes.
It's kind of like we need, the energy is the bounding function.
Correct.
That's what's happening. But yet the stack still kind of emerges. You got a data layer emerging, so it's really robust. It's a full stack. It's almost like cloud went half stack. Now we're back to kind of full stack with energy.
Yep.
So super exciting and for what you guys have done, and you got some funding news. So first explain, what does Normal Computing do? Explain where you guys came from, because it's a great story, and how Google was involved. You guys incubated the project.
Yep.
Now you got some funding news. Tell the story.
For sure. Yeah. So Normal builds AI software with the world's largest semiconductor companies. So right now we're working with more than half the top 10 by revenue semiconductor companies, and we help them design and scale custom silicon, especially silicon that you could consider to have been out of reach before working with us. And in addition to that, we're using our own software and new methodology to bring new kinds of ASICs to market ourselves. Yeah. And the main metric we're focused on is exactly what we were talking about before, which is tokens per watt. So we're helping to bring ASICs to market that are multiple orders of magnitude, 100x, 1000x more efficient for their respective workloads and use cases.
And the funding, big news.
Yes. So we're really excited to announce, sorry, losing my voice, John, already. Really excited to announce that our $50 million accelerator round, which is being led by Samsung, a lot of other amazing investors involved, strategic investors, Micron's in the round. We have Celesta in the round, who's one of Lip Bhutan, the current Intel CEOs, founded firms.
That was his gig. Now it's his side gig.
Yeah, I guess that's right.
He's doing a good job. So yeah, great investor.
Yes.
So you got some heavy hitter chip folks in this deal.
For sure.
One of the things that's interesting to me is that if you go back even 5 years ago, the whole game was you need volume. That's clear. You need volume in the chip business. Intel kind of licking their wounds because of it. Yep. But now you're starting to hear things like we're taping out super fast.
Yes.
So you're seeing, and also the pressure on the American agenda under the current political regime is
correct.
We need productivity in the U.S.
Yes.
So it's almost as if the entrepreneurs are filling the void because now we're seeing new cycles of tape out.
Yes.
Yeah.
What is your take on that?
Yeah, and I think a lot of that pressure is being forced by the super players like NVIDIA who are doing exactly that. I think one of the challenges, though, John, that we're also seeing with our customer base is that, first pass silicon tape out is at a historic low. It's according to Siemens, it's like at a 14% historic low.
Yes.
And so that's one of the crises that we're actually looking to address, which is going in with AI for silicon engineering, start to finish, and using innovation like an Iron Man suit, if you will, for the verification engineers and the silicon engineers across the board, so they're not suffering that ill fate of late silicon surprises being existentially expensive.
All right, so what's the secret sauce? Give us a state of the art, because this is a huge, not only national agenda, as I pointed out, but it's also the demand is off the charts, and also the way these systems were being built
Yeah.
I mean, it's not your classic, hey, here's a motherboard, put a chip on it, put some memory on it. These are engineered systems, and the ASICs are the key because, one little advancement in, say, photonics changes the internet
Correct.
game. I mean, networking is becoming the new silent bottleneck.
Yeah.
So you start to see now, okay, the pressure to configure around GPUs. I mean, Jensen's like, don't make those GPU idles, because that's a sin in the world of infrastructure. Making those GPUs hum is what the goal is, pumping out those tokens.
Correct.
What's your thoughts on that?
Yeah, absolutely. So, broadly, we're making a few different methodological innovations. On the ASIC side, we're pioneering a new paradigm, which we call thermodynamic computing. So the idea of thermodynamic computing is there's two key aspects. One is making it possible to process where the data lives, right? Which means that you're doing actual processing in the memory cells themselves, which helps to resolve some of those bandwidth issues, which are the main reasons that in many cases for LLM inference, you're not kind of maximizing the usage of the chip itself. The second aspect is we're targeting workloads. If you think about AI video generation, some of these most intensive workloads and models, a good example is actually Sora, where OpenAI just shut down Sora a few days ago because it was costing them $15 million a day to run, and that was against $2.1 million in cumulative revenue. The thing about those workloads is that they are sort of noisy and approximate workloads, but we're running them right now on hardware that's 100% deterministic, right? And so the idea with thermodynamic computing, the second aspect of it is we are going to use hardware that is also non-deterministic, and the physics of the hardware matches the workload itself. And so I don't need to maintain these very expensive deterministic zero entropy states. It's a real breakthrough, and it kind of connects to some of the early scientific work we did when we were spinning out of Google, and now we're actually bringing this technology to market. We did our first tape out last year, which we called CN 101, where we kind of proved the kind of physics, and a huge impetus for this round and our next growth is now going through the next phase of tape outs towards production silicon in the data center. Maybe I know you're, as you were talking before the show, very enthusiastic about the edge and decentralized compute. That could be what the future looks like. Physical AI.
I think it's 100% going to be the future. I mean, disaggregated, it's just distributed nodes. So that was a big theme of GTC, disaggregated storage, disaggregated, but all that's the theme. The other theme is unification, which implies connectivity. And kind of harmony between the systems, right? So it's a systems architecture. And switching and co-packaged optics, the trend in co-packaged optics speaks to kind of what's laying right out in front of us, which is networking.
Correct.
That's a huge issue. So you get disaggregated.
Correct.
You need super fast networking.
Yep.
You got to have processing and memory all there.
Yes.
And then you got the energy bounded problem.
Yes.
And form factor.
Yes.
Not everyone can have a monster data center with liquid cooling.
Correct.
This is kind of where it's going.
And I think in that sense, there might be a slide. I think the market is starting to pick up on it now, but we're going to see, I still think, a lot more winners than people realize in this kind of journey and this space in general, right? Because of the way that things are evolving towards heterogeneous data centers, also edge, networking, all these areas. The world is evolving in a way that the data center is going to look completely different from what it does right now in 2 to 3 years, right? And you're going to see a bunch of different players who are coming with custom silicon, different form factors, different solutions that are enabling this kind of future. But I just wanted to add that, from our perspective, the number one constraint which relates to this is energy. It's all about energy in the end, right? So we have to somehow find a way. We're expected in about 2 years to have a 49 gigawatt shortfall of power. That's like, and right now most of the solutions are targeting just finding ways to uncover more energy, make more energy available. I think that's great.
How are you guys fitting into that energy envelope? Because it used to be a data center conversation, but now it's more a pick your node in the network, and so everything that comes out, whether it's a new CPO product switching, if they're not reducing the hops,
Yes.
if they're not reducing the energy,
Correct.
because that energy is going to take away
Yes.
from how many GPUs you can load. Also, the networking increases latency,
Yes.
which is what the GPUs don't want.
Yes.
You need low latency, super great power.
Yes.
Yes.
Where do you guys fit in there? What's the secret sauce? How do you see that unfolding?
It's all about enabling custom silicon, and this idea of radical hardware-software co-design. So the idea is that we're going to have an ASIC for more or less every workload in the data center, right? So right now we're still using a small number of silicon. We're seeing that NVIDIA is starting to disaggregate. So now they have 2 large buckets of training and inference. It's going to disaggregate much, much more to the point where you want to have a custom system, a custom solution for more or less every application that you're running in the data center and beyond. The only way that we can get to that sort of scale is by making it much easier to design custom chips. And that's why the AI software and the methodology that we're pioneering right now with our partners is right at the center. We need to have thousands of more products than we do right now.
What's the timetable? Because obviously this is, you guys are pedaling as fast as you can, obviously.
Yes.
You got partners, you got Micron, you got Samsung, both legends in producing silicon. So, you got that done. Ecosystem is also radically moving fast too. So like you almost have, the pressure points as everyone's going to meet in the middle. I just did a story this morning on Oracle's database is now fully agentic, but their philosophy is keep it all within the database because it's Oracle. But it's not a bad design because they have all the data there. So why not put the agentic origination there?
Makes a lot of sense.
Okay, so if that's going to run, they're going to have a lot of agents running around. So if you got tokens per watt, which is now the key metric.
Correct.
Agents.
You like to say tokens per dollar per watt? Or?
Tokens per dollar per watt, was because it factors in energy's money too.
Yes.
Thanks for that correction.
Correct.
The tokens, agents eat tokens for lunch and dinner.
Yes.
Breakfast, lunch, and dinner. I mean,
Without
they're going to feed on tokens.
Yes.
So whether it's Oracle having a zillion agents or anyone having agents, they got to be fed tokens.
Yes.
What do you guys, so now they got the ecosystem doing stuff. You have vector search, but now you're starting to see agentic.
Yes.
Boom.
Correct.
So you got a hungry market.
Yes.
What's the biz dev look like? How's the business developing? What's the timetables?
Well, let me give a kind of technology perspective on the timetable. I'm sure Craig will chime in on kind of to add additional color. I think that this change is going to happen much faster than people expect, right? So just to give an analogy, if we look at what happened in the software markets a few weeks ago, where basically Anthropic effectively wiped $285 billion in market value from SaaS stocks or software as a service stocks. The reason for that was that they showed that developing an application is much easier than we thought. Now that we have these agentic tools, now that AI has reached a certain threshold on the benchmarks and intelligence scale, software is becoming commoditized. To a large extent, it's becoming commoditized and also democratized, I would want to say. To a large extent, that's part of what we're enabling with products like normal EDA, which is we want to make it radically easier for folks to develop custom silicon solutions using AI. And a large part of that depends on agents and sort of taking this problem of, hey, we have a shortage of silicon engineers that's about 1 million right now. That we're going to make up for that with agents, with AI that's able to actually do discovery and innovation on its own. And this is not a 5 to 10 year plan. This is like a 2 to 3 year plan right now from our perspective.
Yeah. And John, you'll know this from old, whenever a new technology comes about, there's always this kind of rush to embrace the technology and let 1,000 flowers bloom inside organizations, which is like the kiss of death in many respects.
Some of those flowers don't turn into flowers. They're thorns.
Exactly right. So as we're dealing with customers and clients in the market, they're kind of at that stage. And in the silicon engineering space especially, they've allowed it to happen, but now they're coming to us and they're saying, guys, we need a proper solution here to radically change the methodology and radically change the way in which we're designing workflows for silicon engineering.
And I think, that 1,000 flower blooms, I had a big practitioner series yesterday with Mayfield Fund and theCUBE. We're doing a special. We're doing a lot more conversations with people who are the customers, ultimately, of all the AI native companies that you guys are going to enable.
Correct.
The common theme there was, Yeah, it's a double-edged sword. And the old expression was garbage in, garbage out. Now it's like bad data in, bad agents out. So like you have a problem of the 1,000 flowers blooming because they're not all flowers. There are 1,000 seeds being thrown on the soil. And some thorns will grow, weeds will grow, but ultimately they'll be winners. That was one theme. I'm also writing a story right now and doing an analysis on the Y Combinator demo day. And if you look at all the companies that are there presenting, AI is disappearing into everything. So technology is the market here in Wall Street now. Silicon Valley used to be the market for the tech, but it's now come into the capital markets, it's converging. And so my takeaway, and I want to get your reaction, because I think this is kind of in line with your thesis, is that it's not about the software you run, it's the systems you run.
Correct.
So to your point about the commoditization, when the SaaS apocalypse happened on the Anthropic announcement, which I think was way overblown, but to illustrate the point, is software is going to be commoditized, yes. However, if you're a SaaS player and you don't change your product, you're screwed. Okay, so that's the lesson. It's a telegraph sign. Like, look at, you're going to sit around Workday, you're going to get disrupted because soon I get the data moat. So like Salesforce is protected now, but they might not be. So I'm expecting all of them to move to an AI native. But if AI goes into everything, it's not about the software you run, it's the systems you run. Because if it's commodity software, it's already being built. I mean, there's software out there that's helping software compile and run. So there's bug fix software. It's all agents now. So the software development life cycle that we once knew that went to agile is now completely agentic. If that happens, and you believe it does, what's ultimately the value? We think it's the system.
Makes sense.
What do you guys think about that? And how to, because if AI is infused in everything, it's not a category. It's a native ingredient. So then the value goes to, where's the scale? What's the system? What's the use case? How do you process the data? Am I edge case or am I a big factory case?
I would agree. And I know it's, add one additional color there, which is we think it's going to also be the platforms that enable developing those systems, right? So we're going to have to develop more and more systems. What are the technologies and the products that enterprises are going to use to build and scale those systems, right? But in the end, it really is about the systems at the end of the day. And it's, making it easier to close the feedback loops between the products we're developing, whether it's software or hardware, and value, and the metrics that these businesses want to optimize for at the end of the day, right? And actually for us, we consider feedback loops to be a really kind of core part of our thesis. So we ourselves are developing, two both software and hardware with normal EDA and our own normal ASICs. And it's kind of like all about enabling this feedback loop between a software platform you can use to develop radically more efficient silicon, bring it to market faster with less intensive human resourcing, but then also the hardware that you enable in the end. And it creates this virtuous cycle, right? Where ultimately we're going to fully close the loop and you're going to have what effectively looks like AI workloads designing their own substrate that they run on in the end. This is like the radical idea.
The software stack approach is genius because it allows for flexibility. And so it's not, you don't have to kind of pick, we're going to be an HBM alternative.
Right, exactly.
I don't need to, so you can figure out kind of where the demand is. So I guess my question is, with the software stack, is there demand? I guess my question is, what's the demand curve look like for you guys? Is there use cases that are low-hanging fruit? How are you guys coming into the market? You got the 50 million. You're going to run hard. You're going to get great partners, Micron and big investors. What's the plan?
Great question. On the hardware side, we're starting with multimodal generative AI inference. So I mentioned Sora earlier. That's a good example. Video generation, image generation, actually materials discovery, a few different areas there, which are using these kinds of models that we found are super inefficient. And it's one of the biggest areas of growth in Gen AI right now, right? As we move to more multimodal kind of use cases. So that's kind of where we're starting. But to your point, it's really about enabling us to meet demand where it is and as it evolves and continue to target that disaggregation at scale.
So you like disaggregation. That's
the best thing.
That's going to create demand for you guys.
Totally.
And that's going to play out. Inference is hot, obviously. There's more inference coming than we've ever seen before.
I think we're at 2/3 of AI is inference right now. I think 3 years ago was 1/3. I mean, that's a big kind of change that
I
we're
mean, who would have thought the Mac Mini would be a box that people would be buying? So, but that's a tell sign, though. Then you can see someone coming out saying, "Hey, I'm
Correct.
going to build a purpose-built box."
Yes,
that could be an
exactly
entrepreneur
right.
and say,
Yes.
"Hey, you know
Yes.
what? I'm going to code some software.
Yeah.
I'll take a
I mean,
white
ARM
label."
brought to market a CPU, a physical product, for the first time in 40 years, right? And to us, that fits in with this
Yeah.
kind of idea that now it matters to ship custom silicon. Every company is prioritizing
Yeah.
and has a strategy around
And
it.
you can write your own custom software to manage security, identity, compliance.
Exactly.
Yes.
That's a
Yes.
huge issue.
Correct.
I mean, OpenClaw's great, but it's they're running wild.
Yeah.
It's fun. I mean, everyone in the 30s doing it. It's like drugs. It's like tech drugs. How's your OpenClaw going? You don't see any enterprises touching it.
How is your OpenClaw doing? If you don't mind
Doing
me
great.
asking?
It's actually screwed up my calendar this morning. I was running a little bit late, but no, it's fun because what it does is it shows what steady state might look like.
Correct.
That's right.
And
Yeah.
it's really an illustrative point.
Yeah.
And the developers are feeding on it. So like,
Yes.
that's just a great sign of where
It's
this
push versus pull. The agents are working for
Yeah.
you. You're checking in on them. You're managing them. But to a large extent, the workforce is going to be partially agentic. We really believe that.
Yeah,
That's
yeah,
kind
yeah.
of
You said something in your Michael Dell interview, or Michael said, I worked at Dell,
Yeah.
huge respect for the company. And he said, it's going to take about 3 or 4 years to reinvent the entire business,
Yeah.
embracing AI, which I thought was astounding that he's taking a swing at that. It's funny, we're a small company, we're only 3-4 years old. We're reinventing our business on a day-to-day basis.
Absolutely,
Right?
yes,
I can
absolutely.
profess to that.
Yes.
And Faris's point about this beautiful
Yeah.
recursive loop between our hardware and silicon design team and our software design team, the hardware guys are not shy in terms of telling what the software guys
Yeah.
need to do to support their needs. And so we've got this, beautiful cycle to the top in terms of efficacy of software. So it's happening everywhere.
Craig, that's a great point. I want to talk about that for a minute because I'm my pet peeve and love talking about it. In that, there's a lot of cliches, a lot of frameworks people talk about, agile. I pump up systems thinking, kind of get that out there. It's now out there. But when you think about what's going on, it's a generational revolution.
It really
I mean,
is.
and everything you just talked about, even just recently, just in the past couple of weeks,
Yes.
Jensen's comment about token budgets and compensation. You're
Yep.
seeing that already kind of infiltrating.
Yep.
You're hearing companies, if you're not using AI, Amazon's leading this way. Andy Jackson's like, use AI tooling. And if you're not using AI as a tooling, it's already kind of happening, even in the older workforces.
Yep.
Never mind the younger generation. So I'd love to get you guys to weigh in on this because we've seen before and after. We've already crossed the threshold in my mind
Totally.
to a cultural. It reminds me of the '60s.
Yeah.
Totally.
'60s, the freedom of love, drugs,
Yes.
sex, rock and roll. It's kind of like a tech version happening.
Yeah, it is. No,
What is your
absolutely.
thoughts? Because it's like a whole nother mindset. And companies that are sitting around saying, well, can someone do this for me? And if they're not using AI, they're going to be extinct. So the word on the street today is
Yep.
if you are not using AI in your job,
Yes.
you will be replaced.
Yeah, I love
I believe that's going to be true.
Yeah.
So every company is going to start looking at employees and saying, don't be afraid to use AI because, I'm using ChatGPT. No, it's not using. You're not using AI to do your work. You're using AI to augment your intelligence.
That's right.
Correct,
Yeah,
yeah.
indeed.
Talk about this generational thing.
Yeah, so I've been around a bit, right? So I've worked at some really interesting companies over a long arc. So Microsoft, Silicon Graphics back in the day, Sun Microsystems.
Were you in the old Google building, Googleplex, before it
yes,
became
indeed,
Googleplex?
yes, I was.
I'm old. We remember those days.
Oh, they were great days.
Great workstations, great graphics.
Exactly, yeah.
Now you go to.
And so the planning cycle of those businesses, we do a 5-year plan and we meet quarterly, maybe on a 6-monthly basis. That doesn't exist anymore. I mean, we meet daily.
Yes.
And we meet daily to talk about substantive issues in the business and what do we do to fix them. That's the pace at which, that's the cultural revolution you're talking about.
Yes.
You just can't
What
go
are
back to
you? What are you guys doing as just internally? I'm just curious that people could learn from and how you're in your day to day because you guys are running hard and fast,
Yep.
and you guys, essentially 50 million. I won't say seed funding. You're well along, but you're growing.
Yes.
You have targets. You got to get beachhead. You got to move fast.
Correct.
Create value. How are you guys using AI?
We have agentic workflows for everything at this point. I mean, I was telling Craig that my own personal productivity has increased, I think, by almost 10x in the last 6 to 12 months, which is kind of insane when you think about it, right? And so we have multiple evangelists internally at the company, but just to give you a sort of quantitative example of what AI can enable and has enabled our company, for for a long time, certain kinds of software, especially in EDA, which is kind of the core area that we're building in, has been considered almost impossible to build, right? It's like too difficult to build a competitive software product in this area. We had one of our AI leads, who was one of the LM leads at Meta previously, go on paternity leave at the beginning of this year. And he basically...
He got bored. He had to do some nap time, let's code.
Well, his agents coded, right? Yeah. So he wasn't coding. He was on paternity leave doing, I'm sure, what he should be doing. But he set up his agents to run for 43 days. They wrote collectively 580,000 lines of code. And it turned out that in the end, it wasn't bad code. It was really strong software that was effectively able to do this thing at the state of the art that folks thought was impossible previously, right?
So essentially iterate, didn't sleep. Agents don't sleep.
Yeah. Yes.
They were iterating.
But that's a big part of the strategy. It's if you don't have a certain number of agents running and working alongside you pretty much every day while you're sleeping, while you're doing anything else, it's a missed opportunity. And you really have to start now.
I love that example because, back in the day when someone would take leave or go on vacation or maternity leave, it's like you got to go to your manager. Who's your backup?
Yep.
Have a meeting.
Yes.
Here's my workbook. Here's what I'm working on. Don't break anything.
Yes.
And they would just mail it in, just check things. Maybe it's not 100%.
Yep.
Here, he just replicated a digital twin of himself.
Yes, exactly. Yes.
I mean, not simulation, but he was actually using digital and technology to essentially be productive.
Of course, checking in, but it's like we have another person on our team, Eric Meyer, who co-founded one of the AI groups at Meta called Probability. He's very well known for his work in programming languages. So he actually, co-wrote Haskell, C#. So you can think he's a coder's coder by training. Yeah. He has told me that he has not written code for at least over a year now, right? So since that
syntax, getting in, doing all that setup work.
It's management work now.
Yeah.
So everyone's a manager, everyone's a team lead, but it's a different kind of team that you're working with, right? And to a large extent, this is what we're kind of enabling for our partners too, right? So we're going in and working with some of the greatest, most important institutions in the world. Because by the way, this is important, right? Like EDA in our mind is a major choke point. Okay, so right now, China has...
Explain EDA, people might not know it. What is EDA?
Electronic design automation. It's basically the software that people use to design chips. It's an area that hasn't really been disrupted for about 40 years. So the two, major category companies there are about 10 years older than Google, right? And it's an area that's clearly, is in need of motivation, innovation. And, Semicon China is going on right now. We've heard a couple different comments. The VP of EDA at Siemens was kind of saying that, something has to change in EDA for us to keep up. But you can also contextualize it in a kind of broader geopolitical macro way that right now China is about 10% of the way there in terms of their EDA capabilities by certain metrics. And that's one of our strategic modes that we have as the West and allies, many of the companies we work with who are investors in the round. And it's really
Faris,
important.
This is a great point because the AI lesson that we've all learned and people should know if they've come to the conclusion is that the indifference on problems that are ungettable in the past are gettable. Correct. Meaning if you, we can't do that, it's been tried a zillion times. I mean, how many times have you heard that excuse in meetings? Now it's possible. The other thing about your Meta example of your team members that know coding, if you know the domain of something really at a root level, you could actually do the work to understand that language, in this case, programming language, and the underlying principles and primitives, and codify it to scale. That you can apply that to every domain. So that brings up the role of a curator. I call it a curator, artisan, orchestrator. So we're almost going back to the old principles of like, here's a canvas, here's your paintbrushes and colors. Go do something. Which is why I think this token budget's an important concept because you got the paints. I'm paying you $1 million a year or a big salary, and that's what you did?
Yes.
Like
yes,
what?
Yes.
So now we're back to outcome.
Yes.
So there's an artisan craft coming back.
Which is interesting.
And not just architecture. I mean, system architecture, I think, is a standard skill set.
Correct. Yes.
That's been more of an 80s thing. Not just coding, because that's bricklaying. You can just have an agent do that.
Yep.
It's more of, what are we doing? What are the tools?
Yes. Yes.
What am I painting?
Yes.
What am I building?
Yes.
That is a fundamental shift in computer science.
Yes.
Yeah.
Your thoughts?
Well, I think just to pick up on that point, one of the interesting pioneering technologies that we're using in chip design is this thing called auto-formalization, where it takes human prose, thousands of pages of human prose and block diagrams in multiple different formats. And really the design engineer's job is to try and figure out from all of this information what the chip should do and what tests they need to run to make it successful and pass silicon, first time. But it's really difficult and it's awfully cumbersome. So what Faris and the team have done is they've created this auto-formalization technique, which takes this human prose and converts it into a formal language, right? And now our purpose-built AI can understand that. So it's almost like the reverse of what you were saying to a degree. It's taken the craft. It's taken this artisan flair and it's turning it into something that the LLM, the purpose-built LLM, can understand.
Yes.
And so that's part and parcel of one of our advantages in
and that's the idea of agents, right? If you can have a factory of agents, it scales the intelligence of the human.
Yes.
So if you do it right, you have more workers reporting to you, not just an intern, as they joke about ChatGPT. It's like an educated intern from Princeton.
Yes.
How Princeton got in there, I don't know. But go throw Yale in there too, whatever. Some Ivy League Princeton. But now you're going to have systems designers. That is actually compelling because, to your point, agents with systems of intelligence or these factory nodes could decide, oh, build me a new box.
Yes.
Or,
exactly.
Hey, we got a thing at the edge. It's a telco tower. It's got a small cabinet. I need this form factor. I need this power envelope. Go build me a box, lay out an architecture, manufacture it.
Correct.
I need 10,000 units.
And we're not that far.
Verizon might want that. They got $90 billion upgrade they're looking at right now. Refresh.
Yes. That's the next frontier. I mean, you hear folks like Andre Karpathy talking about auto research and just this idea that, we're going to start to move into actual discovery. Right. So right now, key precursor to that is exactly what Craig described, that, the main focus right now really should be codifying intent. Right. So that way the agents can work on designs where we've kind of formalized the intent in some particular way. But subsequently, after we've kind of done that, we're going to be able to innovate on the designs themselves. Right. So AI is going to help us discover architectures and methodologies that are far ahead of our time that we would not be able to discover on our own. So I think it's just going to keep, right? Because we keep thinking we're at the limit of AI, like intern is the limit, and it's going to keep.
Well, certainly it's not normal at this point, but soon to be normal.
Yes.
Normal compute. Guys, congratulations on the
Thank you very much.
Super exciting. We're pushing the limit on the Lex Friedman podcast here.
Awesome.
I can go 2 hours with you guys. It's such a great topic. Very relevant, super cool.
Thank you.
Thank you for coming in. Appreciate it. And
Thanks
we'll
for
be
having us
tracking
on.
it.
Thank you so much.
I'm John Furrier with the AI Factory Series. Again, this is just another example. There is so much work being done. The discovery, the invention, the builders, the operators, and the investors are all coming together. The convergence of technology and capital markets. That's the theme of our program here at theCUBE, the NYSE Wired program. Of course, the demand is off the charts. We're doing our part to bring this content to you. Thanks for watching.